Hello. Well, I have this special edition electronics A275 that I just bought, and it's supposed to work, but before I hook an amp up to the battery or a regular power supply, I like to hook it up to a low current limited power supply just to test some voltages to make sure that it's okay so I don't send it up in smoke. So today I've hooked it up to this little O-scope meter so I can watch the sine wave, and then I'll read down here what the voltage is on the voltage rails. I have it bridged. I'm going across the bridged outputs, and I have it hooked to this current limited power supply. It's set right around 14 volts, but it's limited to about 2 amps. So it can't hurt anything if there's something wrong with the amp. So I'll turn it on, and you can watch this O-scope as I run the voltage up. You won't be able to read it. I'll have to tell you what the voltage is. It's too small to read. Okay, I'll click on the power. Got my 14 volts. Okay. There's a sine wave. Starting out on the sine wave with 14 volts. I should be able to get about 35 is what I need to get the power I'm supposed to get out of it. I already got 41. Okay, I have my special edition electronics A275. I have it hooked up to my regular power supply, 13.8 volt power supply, and a test disc. I have it hooked to my oscilloscope, and I have it hooked to my meter, AMM1 here, and my DD1 distortion detector. And I'm going to do a dynamic power test. See what it does. I want to run it up until the clipping light on the AMM1 hits. $268 at 4 ohm. Okay, I have a special edition electronics A275 amp hooked up. I got my CD player with a disc in it with a continuous 40 hertz tone. I have it hooked to my oscilloscope to see the sine wave, and I got my meter here. This here's the clipping light here, and right here is a 1% distortion light on that one. I'm going to run to 1% distortion. I'm going to put it on real-time power. Okay, start the power supply on. Amp on. Oh, fuck. Well, I screwed up. I hooked this amp up to my smaller power supply there, the current limited one, and I did a bunch of voltage tests and things, and everything went fine. And then I came back and I got sidetracked. Somebody called and I had to go work on something else for a few hours. And I came back to this. And I forgot about something. Well, I ran my dynamic power tests, and everything went fine on those. The dynamic power tests with the regular big power supply, everything went fine. The dynamic power doesn't put that as much load on it, and so then I hooked it up to do my continuous 40 hertz tone and run a dyno up on it. And what I forgot is you never should do that on these PPI amps. You see these transistors, the only way they're clamped down to hold them against a heat sink to dissipate heat properly, you have to have the lid put on. See? It has a lid that has little tabs here. And when you tighten the lid down, it holds the transistors against the sink so they dissipate heat. And the transistor wasn't down against it, and I ran full power to it. This is what happens. Actually, there's a fireball that came off of this. You couldn't see it in the camera, but you could see all the smoke. Hopefully this is the only one damaged. It doesn't look to me like it has damaged the board any, to where I'm going to have a problem with it. But all four of these FETs could possibly be damaged, and I could have damaged some other parts. I hope not. Anyway, I have some of these same ones, used parts from another amp, and I probably have some replacements, new ones. Anyway, I'm going to have to go take this board out and fix the jarred place and see what kind of damage I have. And then I'll try to repair it.